In this lesson, we're going to be trying to see if the roots that we're given are a solution to the given quadratic equation. So when they give us the roots, they're telling us the answers, the solutions, where the graph crosses the x-axis. So they're going to ask us, the roots are -1 plus or minus 2i. So they're really giving us two roots. One of them is -1 plus 2i. The other one is -1 minus 2i. Now, some of you will be wondering, well, couldn't I just solve this equation, and if I get these as my answer, then I know they're the given roots? That is one way you could do this. I'm not, however, going to let you do it that way because we know how to do the quadratic formula. I want us to be able to work backwards. And so on your test for this chapter, I'm going to look to make sure that you did work it backwards to get your full credit. If you work by doing the quadratic formula, you'll lose points for that because I want to make sure you can go forwards and backwards on this. In the big scheme of things, like on an ACT or something, you could always choose that method, but I want you to practice that for this chapter to see if you can work backwards. So when doing that, when they're giving us the roots, they're really telling us that this is what x equals. They're saying x equals -1 plus 2i and x equals -1 minus 2i. You might remember doing one like this in your Excel math last chapter. Everyone had one or two of these that they had to do. So what we do from here is we're basically doing our factoring backwards. So I'm going to now solve both equations and get them equal to 0. So I'd add 1 and minus 2i from both sides. So here I'd have x plus 1 minus 2i, and then my sec equals 0, really. And then over here I'd add 1 and add 2i. So I'd have x plus 1 plus 2i equals 0. And then I'm going to try to factor them. So I write each factor, x plus 1 minus 2i, there's one factor, and x plus 1, oops, not quite done, x plus 1 plus 2i as my other factor. And now, if you remember doing this before, you kind of end up with some crazy stuff, but you're going to FOIL this all out. So I'm going to distribute my x to all three spots. So as I do that, I would have x squared plus x plus 2ix. Looks weird, but it's going to work out. Then I'm going to distribute my -1 or my +1 to all three spots. So I have plus x plus 1 plus 2i. And lastly, I'll distribute my -2i to all three spots. So minus 2ix minus 2i minus 4i squared. And all of that still equals 0. So as I'm simplifying this right now, my i's should all cancel out or somehow leave this part of my equation because I'm not going to have an I in my answer. So when I look here, I have 2ix and -2ix. Those add up to 0. I have 2i and -2i. Those add up to 0. So the only other I have here is this I squared. Well, we know I squared is -1. So instead of a -4 here, this actually becomes a +4. So when I look to combine like terms, I have x squared, and I have 1x plus 1x, which is 2x, and then I have 1 plus 4, which is 5. So I end up getting x squared plus 2x plus 5 equals 0. This isn't my answer. My question was, are the given roots a solution to the given quadratic equation? If you remember, our given quadratic equation is right here. And I didn't get a 6 there, I got a 5. So I actually will answer the problem by saying no. Those given roots are not a solution to the given quadratic. I want you guys to try number 2 now and see how you do with that one. Actually, you could probably do 2 and 3. And then I'll run through those and show you the work for those a little bit quicker. And you can check if you did those right. So do 2 and 3 quick. there's what I get for number 2. That is the same as my original problem, so this answer would be a yes. On to 3. As I combine like terms, my i's are gone, gone, gone. -1, so this ends up being a plus 4. So I have x squared plus 6x, and 9 plus 4 is 13. X squared plus 6x plus 13 equals 0. That is my original problem they gave me, so this is a yes. So there's all the ones you do with an imaginary solution. Now we're going to try when we don't have imaginary. So this answer here for number 4, I have x equals -2 plus the square root of 5, x equals -2 minus the square root of 5. I think you maybe can move these over without showing work, so I would add 2 to both sides and minus the square root of 5. And over here in my second root, it's x plus 2, and then add the square root of 5. So I'm going to do the same process here. I'm going to distribute this x to all 3 parts. So I have x squared plus 2x plus x root 5. Then I'm going to distribute my 2 to all 3 parts. I would have plus 2x plus 4 plus 2 root 5. And lastly, minus x root 5 minus 2 root 5 minus square root of 5 times the square root of 5 would be the square root of 25, right? So you could write it like that, or you can just go straight into a 5, however you prefer. So as I'm looking now, the nice thing is, look at my square roots. They are canceling out. So I have x squared plus 4x, and then 4 minus 5 would be not a plus sign. How about a minus 1? That is not the same as my original problem, so this one is a no. Let's let you guys go ahead and try number 5. So pause the video, do it, and then you'll see me work it out. I do get the same as the original, so this is a yes. Number 6 now. This one is a little more work, right? So when I set each problem equal to 0, or each factor, I have -1 plus I root 15 over 4, and x equals -1 minus I root 15 over 4. So the first thing I have to do here is deal with the fact that this whole equation is being divided by 4. So I would choose to times both sides by 4, so that these 4's cancel. So I now have 4x equals -1 plus I root 15, and 4x equals -1 minus I root 15. Then it looks kind of what I had before. I'll go ahead and move over that 1 and the I root 15. Again, move over the 1 and the I root 15. So now as I distribute, the 4x goes to all three spots, so I have 16x squared plus 4x plus 4ix root 15. Take a look at that one. That one looks a little weird, right? But it's right. So now we'll go on to the ones. So that one, really nothing changes because we're timesing by 1. And then lastly, I'll distribute negative I root 15. So negative I root 15 times 4x would be negative 4ix root 15. Negative I root 15 times 1 would be negative I root 15. And negative I root 15 times negative I root 15 would be negative I squared root 225. And then I have an equal 0 over here. Pretend like you can see it on the way right. So now I'm going to see what cancels. This 4ix root 15 and negative 4x root 15. I root 15, negative I root 15. So it's looking good. Right here, the square root of 225 is really 15. And since I squared is negative 1, I would have a negative times a negative 1 times a 15. So this ends up being positive 15. I have a plus 15 at the end. So when I combine like terms, I end up with 16x squared plus 8x plus 16 equals 0. That is not my original problem. But look at how they're very similar. Look at your original problem they're having you check and the answer that you got. Do you notice anything about them? Hopefully you see that if I just divided everything by 8, they'd be the same. And you have to look for that. That can happen to you. So when I divide everything by 8, I'm checking them. This would be 2x squared plus x plus 2. And 0 divided by 8 still is 0. So they are the same. It can be a little bit disguised. And that's because we had to divide by 4 in the beginning, so multiply by 4. But it is the same. So that's a yes. Our last one we're doing here, they gave us 5 different roots. So here's our 5 roots. X equals 0, x equals 4, x equals negative 4, x equals 4i, x equals negative 4i. This is a lot of work here, right? So I'm going to go ahead and get all my x's equal to 0. So x equals 0 is just the factor of x. So I'm going to have x times, here to get it equal to 0, I have x minus 4 times x plus 4 times x minus 4i times x plus 4i. So I have 5 different groups that are being multiplied. What I would choose to do first is group the ones that kind of went together, and I would FOIL those out first. You don't have to. It's not the only way to do it. I think it's the easiest way to do it. So I'm going to go ahead and bring down this x that was already there, and I'm going to FOIL x squared plus 4x minus 4x minus 16. Then I'm going to FOIL up my other pair, x squared plus 4ix minus 4ix minus 16i squared. So now, as I'm simplifying these, I notice this cancels here. So I have x times x squared minus 16, and then here these cancel. And I squared is negative 1, so this is really going to be a plus 16. So I have x squared plus 16. From here now, and again, you're multiplying numbers. So when you multiply numbers, you just multiply 2 at a time and then go times the next one. So I can choose how I do it now. I'm going to, again, choose to group these. So I'm going to have my x times, and I'm going to distribute my x squared to both, and then my negative 16 to both. So when I combine like terms here, these are gone. I have x times x to the 4th minus 256 equals 0. So I go ahead and finally distribute my x. X to the 5th, remember we had 5 answers, so that makes sense, minus 256x equals 0. Is that my original problem they gave me? It is, so this one is a yes. So you're going to have problems like this on an objective actually, and hopefully you can you'll have one example you can check in your notes that will help you with any of them you have questions on.